Okay, the last part for the practice final test, part 3. Here we go. Okay, first we have to find the constant of proportionality for this XY t-chart. Although it's set up slightly differently, it still is. So the constant of proportionality we know is always set up so that K, which is our constant proportionality, is equal to Y divided by X, or we should know that it's wherever X is equal to 1. So K is equal to 4 divided by 1, which of course is going to equal to 4. But again, wherever we see X equal to 1, we know that that is also the constant of proportionality to make our lives that much easier. Okay? Next, this table shows a proportional relationship between X and Y. Find the constant of proportionality, R, they call it in this particular one. So R is going to be our K. R equals, so R equals Y divided by X. So R equals 48 divided by 4. Hopefully you know your 12 times tables because that means R equals 12. And then I'm going to write the equation in this form. Remember, that just means that I have dropped down X into this table and multiplied it times R. R is 12. So that means it's 12X. So therefore, Y is equal to 12X. Y equals 12X. There it is. Which of the following is an equation for the constant of proportionality? Well, we have been doing a bunch of these, right? Which one of these is the equation for the constant of proportionality? Well, you should know that the constant of proportionality is our K, and they're all set up for K. And you know that K is equal to Y divided by X. There it is. Okay, so we still know that we are using our XY chart, but we have to be careful here because this says that our chart is directly proportional to the volume of the pool. And they have not set this up the way that we want it to if the proportionality is proportional to the volume of the pool. Because remember, our XY, if it's proportional to something, that means we want this to be our X, and it's therefore on the wrong side. This needs to be our X. So we're going to flip it around. So this is when we have to be careful of the language, specifically that word to right there. So we're going to flip it around so that our X, which in this case is the volume, is on the left. So I'm going to have 2,500 to 5, 5,000 to 10, and 7,500 to 15. Now, once again, let's not forget that K is our constant of proportionality, which is always equal to Y divided by X, right? This is my X and this is my Y, but they've used different values, but it really doesn't matter because when I look here, all of these, none of them actually have X or Y in them, so it's irrelevant. So I'm going to go ahead and divide Y divided by X. Okay? So y divided by x, I'm going to choose, I can use any one of these, but I'm going to choose to use this one. I like those numbers better when I manipulate them. Y divided by x is going to be 10 divided by 5,000. Mrs. De Silva, why do you like those numbers better? Well, look at this. Get rid of those zeros. That's going to equal 1 over 500. 1/500th. Well, these are all decimals. How's that helpful? Well, let's put these into my 10th, 100th, thousandths, etc. So if I want to do that, let's put this down here so I can see it better. I want this to become 1,000. 500 to 1,000. Well, that means I'm going to be multiplying it times 2. That would make this times 2. 2 thousandths. I'm going to write that in its decimal form. Remember, this would be a 1 here. 2 thousandths. 0. Thousandths means there's going to be 1, 2, 3 decimals. And the 2 is going to go in that thousandths place. 0, 0. Look at that. My choice is A. Next, recipe to use 4 cups of flour to make 56 cookies. Constant proportionality that relates the number of cookies made, y, oh, even gives it to us, to the number of cups of flour used, x. I love when they do that. X, y, flour, and cookies. How much flour? So there's 4 cups of flour to 56 cookies. Okay. Constant proportionality, I know, is going to be K equals 56 divided by 4, right? 4 goes into 1 time with 1 left over. And that, of course, is going to be 16. 4 goes into 16 4 times. So K is equal to 14. Or, remember, that's my unit rate. So there it is. My choice is D. Next. May is filling her fish tank. Water flows into the tank at a constant rate. Complete the table as you answer the questions. What is the constant proportionality? And I want to fill in each of these. Water, gallons per minute. Okay. K equals, this is X, this is Y. 8/10. 0, yuck, that's funny looking. So it's 0.8 divided by 0.5. I know what you're thinking. Like, Mrs. De Silva, those numbers are icky. I can't do them on my calculator. I mean, I can't do them without a calculator. So that is fine. Oopsie. So that, of course, is going to equal 1.6. K equals 1.6. That is fine. So that means everything from left to right is going to get multiplied by 1.6. And then, of course, in the opposite direction, we're going to divide by 1.6. Right? So 1 times 1.6 is, of course, 1.6. 3 times 1.6. Again, these are more than appropriate times to be using your calculator. This is 4.8. Well, now I've got 40. I'm going in the opposite direction, so I'm dividing. And this answer is 25. That's a beautiful thing. First question, is this a proportional relationship? Well, what are we going to do? We are going to divide all of these y by x and see if they are the same each and every time, right? So 2 divided by 6 equals 1/3. 3 divided by 9 equals 1/3. 8 divided by 24 equals 1/3. And 1/3, of course, equals 1/3. Is this a proportional relationship? Yes. If it's a proportional relationship, what is the constant of proportionality? Well, hopefully it's clear to you, because every one of these is the same, that it's 1/3. If this is a proportional relationship, write a direct proportion equation. Well, that of course is always y equals kx, where this is my k. So y equals 1/3 x. The table represents a proportional relationship. Which graph represents a proportional relationship with the same unit rate as the table? So really, we only need to look here, to be honest. X, Y. I'm going to turn my table here, so X, Y. One, 4. Hopefully you remember to always run, then jump, because we look funny when we jump, then run, right? So it means we're going to run across until we get to 1, run across to 1, and then jump up to 4. So I'm immediately going to notice that every one of these, 4 is up here, right? So A and B never even really get up there, at least not near the 1. So I'm looking at C and D. 4 is here, doesn't get up there at the 1. So here's my 1, and there's my 4. So my correct answer is choice D. Next. Which table shows a proportional relationship between x and y? Okay. So we know each and every one of these, we have to divide y by x. Okay. Let's see. We'll start here with A. So this is 4/3, right? 10/6, 10/6. that goes into is 2. 2 goes into 10 5 times. 2 goes into 6 3 times. So it can't be A. Let's look at B. We've got 6 over 12. They share a gazenta of 6. 6 divided by 6 is 1. 12 divided by 6 is 2. Okay, so it's 1 half. If I look at this next one, 12 over 14. We can already tell that that is not 1 half, right? Not this one. Next, 2 fourths equals 1 half. 4 eighths equals 1 half. 8 twelfths is not going to equal 1 half. They share a gazenta of 4. 4 goes into 8 twice, and 4 goes into 12 3 times. Can't be C. I sure hope that it's D. So 1 fifth, 2 over 10. Goes into they share is 2. 2 goes into 2 once. 2 goes into 10 twice. That's 1. Wait, 2 goes into 10 5 times. Sorry about that. 1 fifth equals 1 fifth. Next, I've got 3 over 5. The goes into they share is 3. Not 3 over 5, 3 over 15. 3 goes into 3 once. 3 goes into 15 5 times. Looking good. 4 over 20. That goes into they share is 4. 4 goes into 4 once. And 4 goes into 20 5 times. And last but not least, should be fairly obvious by now that this is our answer, but let's be sure. 5 over 25 equals 1 fifth. Looks like this is the one. So here we are. D is our answer. Next, 2 quantities are proportional. What must be true of the graph? Showing the relationship between them. What must be true? Okay. The graph is a curve. If it is proportional, nope. Points in the graph are connected. Points in the graph are connected. Well, if it's a proportional relationship, they should form a line, right? We've definitely said that. The graph increases from left to right. Yep, because it has to start from 0, right? Okay. The points of the graph form a straight line, always, linear relationship. Points of the graph must include the origin. To be proportional, absolutely. Points on the graph must form equivalent ratios. Yes, they must. Next. This table represents a proportional relationship. Write an equation that represents the relationship. Easy peasy, lemon squeezy. Have to find the constant of proportionality. We know that that means we're dividing, in this case, h by t, but we know deep down that this is x and y, because k equals y divided by x. In this case, it's k equals h divided by t. So, once I have h over t, that's 5 over 2. So now that I have k equals 5 over 2. I can now write my equation, which is y equals 5 over 2x. There you go. Next. I didn't skip one again. Skip one. Did. Okay. Find the percent change to the nearest whole. This is exciting. Okay. From 45 feet to 95 feet. Percent change. In other words, how much did it change from 45 to 95? So first of all, we know that it increased, right? So it went from 95 to 45. 95 divided by, not divided by, subtracted by 45 equals 50. So that is the actual change. Right? Then I'm going to make my t-chart, x, y. My percent change is up here as k. And now I just need to know my input and my output. So it went from 45, so that's definitely my input. Is 45. And my output, because it wants the actual percent change, not altogether, is 50. So I say to myself, what do I multiply 45 by to get to 50? Nobody obviously knows. So I'm going to divide 50 divided by 45. And what am I going to get? I get this 1.11. It continues to repeat. And then I have to change that to a percent. Move it down here. In order to change it to a percent, I do need to move my decimal 2 places. Give me 111%. And I knew that it was an increase. So there you go. Part D, or number D. Variable D is our answer. Percent. Next. 24 students in a class took an algebra test. 18 students percent passed. What percent passed? I'm going to use my XY. What percent passed? So 24 started. $18 students passed the test. What percent passed? So 18 goes here. All I need to do is find out what K is. So I need to divide 18 by 24. That equals 0.75. I need to change that to a percent. I change it to a percent. I go 1, 2. Equals 75% passed. Next, $79 television on sale for $65. What's the percent discount? What's the percent discount? In other words, how much is taken off? So first thing I need to do is figure out how much less, right? So how much less? I'm going to say 79 minus 65. I don't have to do this, but then I have to do some subtraction later. So 79 minus 65 equals 14. That's the actual change. So now I want to find out the percent discount. So I'm going to use my input output, in, out. So in, I know 14 comes out. $79 was the original. So put 79 in, out comes 14. I'm going to divide 14 divided by 79 equals 17.7 or 17.72. What percent discount was given? I'd say we're probably safe. Oh, well, we already have to look at this. They rounded it here to the 1%, the ones place. So there's my answer, 18%. Next, select all that show a 16% increase or decrease. Interesting. So basically, I'm looking at increase or decrease. And increase or decrease, I want to take this first number every single time, and that's my input. So I'm going to make that my x. 60, 24, 36, and 42. I'm going to make 16% as my k. I'm going to try and figure out what y is every single time. I'm going from left to right. It means I multiply, right? So I'm simply going to multiply each one of these. So 60 times 0.16 equals 9.6. 24 times 0.16, 3.84. 36 times 0.16, 5.76. 42 times 0.16, 6.72. Now it says increase or decrease. So that means I need to look at if it's an increase, I can add them, see if I come up with the same number. I can already tell that for this one I can. I do. 60 plus 9.6. A is correct. 24 to 27.12 is an increase. Those are not the same because it ends in 1, 2. This ends in 8, 4. 36 is a decrease, right? So I'm going to use my calculator to subtract 36 minus 5.76. 30.24. So this is not. This is also a decrease. So I'm going to go ahead and subtract 42 minus 6.72. Wait, what? 42 minus 6.72. 35.28. Look at that. So A and D work. Nancy is buying new boots. The store is having a sale, 20% off. I need the drop-down menu, which I did not copy here, so give me a moment, and I will gather it from my computer. This will not take long. We're just going to have to be patient. So the choices are 0.2x, 0.8x, or 1.2x. Okay, got all my choices here. Okay, choose an expression that can represent the sale price of the boots where X is the original price. So this is a perfect opportunity for me to use my tape diagram where this is 100%. The sale price means it's a decrease, right? So it means it's going to be less than 100, and it's 20% less. So if it's 20% less, that means what's left here is 80%. Change that to a decimal, it's going to be 0.8x. And then the sale price of the boots is 80% of the original cost. Nice. Last month, Carmen made $480 working for 30 hours. This month, she gets a 15% increase in the amount she earns per hour. What will be her hourly rate in dollars per hour after the increase? Okay. 15% increase. Okay, so here's my tape diagram. 100%, 15% increase. So it's 1 plus 0.15, 1.15 hourly rate. Oh, first we have to figure out the hourly rate. So that's $480 for 30 hours. So 480 divided by 30. Go ahead and use your calculators. $16 per hour, 1 hour. And then we want to find the hourly rate after the increase. So that means I'm going to take my X going to be multiplying it times this. So that it'd be like my y equals 1.15x. So our new hourly rate is $24 per hour. Wait, I think I put that in wrong. 16 times 1.15 equals, yeah, I put that in wrong. What I put in was 1.5. I knew it was too high. Always, always check your work. The correct answer is 1840 per hour. Percent change from 6,000 to 9,000. So of course, the first thing we need to do is subtract. That of course is a difference of 3,000. So then, I mean, honestly, we don't even need a calculator for this because we know if we start at 6,000, we should know automatically that 3,000 is 50% of 6,000, right? Or 1/2, right? So it's a 50%, and this, of course, is an increase. So it's a 50% increase. That was an easy one. Last one. On Monday, the high temperature was 80 degrees. The high for Tuesday was 60 degrees. What is the percent change in temperature from Monday to Tuesday? Okay, so on Monday, it was 80. On Tuesday, it was 60. Okay, so the change itself would be 80 minus 60. So that's 20 degrees. It's the actual change. This, of course, you should notice is a decrease, right? From Monday, so Monday is the original. Percent change. So here we are, my input is my original, that's 80. My actual change, so what comes out is 20. So I'm looking for the percent change, which is K. So I'm going to divide 20 divided by 80. This is another one, honestly, you do not need a calculator. Get rid of the zeros. You've got 2 over 8, which is equal to 1/4, which in percent, that is, well, it's 0.25. That's my decimal, but it's asking for the percent change. So that is a 25% decrease. There's your answer. And that is all we have. And that's our last part.